Hello all. In today's video, I'm going to talk about expectation and variance of a random variable. So let's start with something basic and then I'm going to extend it to the concept of expectation. Imagine you are in an introduction to probability class with 50 students and you have just taken your first exam. After the exam, everybody wants to know the average score. Now, the question is, how do we find the average? In this scenario, each student's score is equally likely to be selected if we were to choose one at random. Let x1, x2 till x50 denote the score of 50 students that are in that class. To find the average, we add up all the scores and then divide by the total number of students. So if x1, x2 till x50 denotes the score of all the 50 students that are in that class, then the average would be x1 plus x2 till x50 and then divided by total number of students, that is equals to 50. This gives us the average score for the class. The idea of equally likely outcomes is important in basic probability, but we'll soon see how expectation handles cases where outcomes are not equally likely. Okay, let's consider a slightly different scenario. Suppose we have 3 different exams, but they are not equally likely to be given. Exam A has a 50% chance of being given, exam B has a 30% chance, and exam C has a 20% chance. This means that if the instructor were to choose an exam to administer, there's a 50% probability or half probability that they would select exam A, 30% probability that they would select exam B, and 20% probability of selecting C. If we want to find the average score, we need to consider not just the scores themselves, but also how likely each exam is. This is called weighted average, and it's a key step in understanding expectation. Say the average scores for the exam A, B, and C are 75 points, 80 points, and 70 points respectively. If we want to find the average or expected score, we need to consider not just the scores themselves, but also how likely each exam is to be given. To calculate this weighted average, we multiply each exam's average score by its probability of being given, then sum these products and divide it by the sum of the probability of being given for each exam. So the weighted average in this case would be equals to 0.50, which is the probability of exam A, times its average, which is 75, plus the probability of exam B, which is 0.30 times its average score of exam B, which is 80, plus the probability of exam C, which is 0.20 times the average score for exam C, which is 70, and then divided by 0.50 plus 0.30 plus 0.20, which is the sum of the probability of exam A being given, exam B, and exam C. So the weighted average or expected score is 75.5 points. This takes into account both the scores and the likelihood of each exam being given. So a weighted average is the average of values which are scaled by importance. The weighted average equals the sum of weights times values divided by the sum of weights. Let x1 till x2 till xn be data with weights w1, w2 till wn respectively. So the weighted average is the sum of each data point multiplied by its corresponding weight divided by the sum of all weights. So in probability, we have a concept called expectation that extends this idea of weighted averages. The expectation is like the average outcome you would get if you could consider all possible outcomes and their probabilities, where there are finite number of outcomes or an infinite number. So expectation is basically a generalization of the weighted average. Let's try to understand it with an example. Let x be a random variable representing the outcome of rolling a fair six-sided die. So the support of X would be 1, 2, 3, 4, 5, 6. So basically the support of X is all the possible values X can take. So if you are rolling a die, then X can take value 1, 2, 3, 4, 5, or 6. If you roll the die 7 times and get numbers like 2, 4, 6, the third time, 1, 3, 5, and 2 at the 7th time, you would add them up to get 23. Then you divide by 7, since you roll the die 7 times. And when you divide that sum 23 by 7, you would get 3.29, which is the average value of your rolls. So the average value of your roll is approximately 3.29 over here. Now, imagine you could roll this die an infinite number of times. So the expectation is like a magic number that predicts what the average value would be if you did this endless rolling. It's a theoretical average that considers how likely each outcome is. For a fair six-sided die, where each number is 1, 2, 3, 4, 5, 6, because you are rolling a die, so these are the possible outcomes you can have. So all these outcomes occur with the probability 1 by 6. So the expectation would be 1 times the probability with which you can get 1, which is 1 by 6, plus 2 times the probability with which you can get outcome 2, which is 1 by 6 again, plus 3 times the probability with which you can get 3, which is again 1 by 6, and you keep doing it for all the possible 6 values, and you get that your expectation is 3.5. This means that if you could roll the die forever, the average value of your rolls would tend to be 3.5. Now, what's the connection between average value and expectation? So average value is based on what actually happens in a limited number of trials. Expectation is a prediction based on probability and assumes an infinite number of trials. The average value you get from actually rolling the die a number of times tend to get closer and closer to the expectation as you roll more and more times. In essence, while the average value tells you what happened based on your rolls, the expectation tells you what would happen on average if you could roll the die forever. They are related because as you roll more times, your observed average gets closer to the expected value predicted by probability. It's important to note that expectation of X does not necessarily correspond to a possible outcome of a random variable X. For instance, in this case, 3.5 is not a possible outcome of rolling a six-sided die. It represents the average outcome over many rolls. So always remember that E of X, expectation, does not correspond to any possible outcome of the random variable. It's just the average outcome over infinite number of rolls. The expected value of a discrete random variable X with probability mass function Pxk is given by summation of k times Pxk, where summation is done over the support of the random variable X. It is denoted by mu or E of X. It is understood as estimate of the average value that the random variable will take. Okay, an important thing is the expected value of a discrete random variable is defined only if summation taken over the support of the random variable of absolute value of k times the PMF of x at k is less than infinity. So if expectation of absolute value of x is finite number, only then the expectation of a random variable is defined. If it is equals to infinity, then the expectation of a discrete random variable is not defined. Let's try to understand it with an example. Consider the following game. Toss a six-face die 2 times. If the sum of the two values is 4 or lower, we have to pay $10. If the sum of the two values is 5, 6, or 7, we pay $5. If the sum of the two values is 8 or 9, we earn $5. if the sum of the two values is 10, 11, or 12, we earn $10. And now we have to find what are the expected winnings. Okay. So since we are rolling a six-sided die 2 times, the sample space will contain all the possible outcomes you can get when you roll the first die and all the possible outcomes you get when you roll the second time. So when you roll the first die, the possible outcomes are 1, 2, 3, 4, 5, 6. And when you roll the second die, you would have the possible outcome would again be 1, 2, 3, 4, 5, 6. So this is how your sample space would look like. So the question is, if the sum of the two values is 4 or lower, we have to pay $10. The question is somewhere asking us to sum the two values we are getting when we are rolling the die twice. So we define the random variable x as the sum of two values on the die. If you define x to be the sum of two values on the die, then x can take value 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So when we say adding, what do we really mean? These are the possible outcomes we have in the sample space. If you add the two values, that is 1 plus 1, you get 2. If you add 1 plus 2, you will get 3. And now if you look at the last outcome, like the maximum value x, when you roll a die, it can take a 6. And again, when you roll it again, the maximum value it can take is 6. If you add those two maximum value, you'll get 12. So as I mentioned before, support of a random variable is the possible values the random variable x can take. So here, s of x would be equals to 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But the question says that if the sum of the two values is 4 or lower, we have to pay $10. So let's find what would be the probability when the sum is 4 or less than 4. So what are we doing? We are finding the probability of x when it is equals to 2 or 3 or 4. So if you add 1 plus 1, you get 2. So this outcome lies in the event x less than equals to 4, because the sum of 1 plus 1 is 2, which is less than equals to 4. Again, if you sum 1 plus 2, you get 3. 1 plus 2 is less than equals to 4. So this outcome also lies in the event x less than equals to 4. So if you look at 2, 1, the sum of these two values is equals to 3. Therefore, it lies in the event x less than equals to 4. Similarly, 2 plus 2 lies in the event x less than equals to 4. Also, 3, 1 lies in the event x less than equals to 4. So these are the only outcomes that lie in the event x less than equals to 4. If you count the number of outcomes that are in the event x less than equals to 4, you get that total number of outcomes in that event is 6. And the probability of any event is equals to the cardinality of that event divided by the cardinality of the sample space. So you get 6 divided by 36, which is equals to 1 by 6. Next, we have probability when x is equals to 5 or 6 or 7. So you go back to the sample space, you look at all the possible outcome where the sum of these values is equals to 5. Plus, you look at all the outcomes where the sum of the two values is equals to 6. And then you look at the outcome where the sum of the values is equals to 7. You add them up and you will get that probability that x is equals to 5. 6 or 7 is equals to 15 divided by 36. You follow the same steps for probability x equals to 8 x or 9, probability x equals to 10 or 11 or 12, and you should get that the probability x is equals to 8 or 9 is equals to 1 divided by 4, and probability x is equals to 10 or 11 or 12 is equals to 1 by 6. Perfect. But are we interested in the sum of two values? The answer is no. We are actually interested in the expected winnings. But the reason we defined the random variable x was because somehow the winning is related to the sum of these two values. Okay, time to define a new random variable, which is w. So let w be the winnings in the game. Okay, now what does the question says? The question says that if the sum of the two values on the die is 4 or less than 4, then the player will have to lose $10, give $10 away. If the sum of the two values on the die is 5, 6, or 7, then the player will have to give away $5. And if the sum of the two values on the die is 8 or 9, then the player will receive $5. And if the sum of the two values on the die is 10 or 11 or 12, then the player would again receive $10. So W can take values -10, -5, 5, and 10. Again, why? Because the player will have to give away $10 if the sum of the two values on the die is 2 or 3 or 4. In that case, W takes the value -10. Okay, so now we know the support of W, and now we will define the PMF for W. Now W can take value -10, -5, 5, or 10. So we will have to find what would be the probability of W at -10, -5, 5, or 10. So we know that W can take value -10 when the sum of the two values on the die is 4 or less than 4. And that happens with the probability 1 by 6. Therefore, probability of W is equals to -10 is 1 by 6. Similarly, we know that the player will have to give away $5 when the sum of the two values on the die is 5, 6, or 7. Therefore, probability of W is equals to -5 will be same as probability that X is equals to 5 or 6 or 7. That is equals to 15 divided by 36. Similarly, probability of W is equals to 5 would be same as probability that sum of the two values on the die is 8 or 9. Again, why? Because the player will receive $5 if the sum of the two values on the die is either 8 or 9. And similarly, probability that the player receive $10 will be equals to 1 by 6 because the player is going to receive that money if the sum of the two values on the die is either 10 or 11 or 12. Perfect. So now we have the PMF for the random variable W. Let's find the expectation because that's what we have to find. We have to find the expected winning. Expectation of W is equals to summation K times the PMF of W, where summation is taken over the support of the random variable W. So now K can take value -10, -5, 5, 10. And what are we trying to do? We are multiplying -10 with its probability and adding it with -5 and its probability plus 5 with probability with which W takes value 5 plus 10 times probability with which random variable take value 10. We already have the PMF of the random variable W. So we plug in the value of the probability when W takes value -10, -5, 5, 10, and we get that E of W is equals to -0.83. And this means that on average, you would expect to lose 83 cents per game if you played this game many times. So what is basically expectation? Imagine you have a magic crystal ball that could show you all possible outcomes of an uncertain event and how often each outcome occurs. Expectation is like taking all the information and boiling it down to one number that represents the typical outcome. Perfect. Let's say we are given with a discrete random variable X, and we know the probability distribution of that random variable, and G is any real valued function, then the expectation of G of X would be equals to summation G of K times probability of X at K, where summation is taken again over the support of the random variable X. So let's consider the same example of expected winnings. And let me define G of X is equals to X to the power 4. In that case, expectation of G of W will become expectation of W to the power 4. And how do we find expectation W to the power 4? It is just summation K to the power 4 times Pxk. Now remember, we are not raising the probability to the power of anything. We are raising K to the power 4. And again, the summation is taken over the support of the random variable W. Okay, so now K can take value -10, -5, 5, or 10. If we put those values over here and multiply with its probability, we will get that expectation of w to the power 4 is equals to 3750. So if g is any real valued function, we can always calculate the expectation of g of that random variable by using the formula given over here. Let me define the notion of variance now. So the variance of a random variable with expected value mu is given by, now again, wherever you see mu, you just it just means that it is the expectation of any random variable. So the variance of a random variable is defined as expectation of x minus e of x whole square. So what are we basically doing? We are finding the expectation of the variable x minus e of x whole square. So it is equals to summation k, where k comes from the support of x, and k minus e of x whole square pxk, where summation is taken over the support of the random variable x. Variance is a statistical measure that quantifies the spread or dispersion of a set of data points around their mean or average value. Basically, it provides information about how far the numbers in a data set typically deviate from the center or from the average. A larger variance indicates that the data points are more spread out. A smaller variance indicates that the data points are clustered closer to the mean. So now variance of x is equals to expectation of x minus e of x whole square. So now if you try to use the identity a minus b whole square is equals to a square plus b square minus 2ab, and you get x square plus e of x whole square minus 2x e of x. We know that expectation is linear. Therefore, expectation of x square plus ex whole square minus 2x ex will become expectation of x square plus expectation of ex whole square minus expectation of 2x e of x. Expectation of x is typically a number. If you take expectation of a number, you get the number itself. Therefore, if we take expectation of the second term, we get expectation of x whole square. If you take expectation of this third term, which is 2 times x times e of x, now 2 is a number, you can pull it out of the expectation sign. E of x is a number, you can pull it out of the expectation sign, and you will be left with twice expectation of x times e of x. So twice expectation of x times expectation of x is twice expectation of x whole square. If you simplify it further, you get that variance of x is equals to e of x square minus e of x whole square. So an alternative method to find variance of a random variable x is equals to expectation of x square minus expectation of x whole square, which you basically obtain from the original formula. Basic simplification has been done to get to this simplified formula. Variance is expressed in squared units of the original data. When we calculate variance, we square the difference between each data point and the mean. This squaring process changes the units of measurement. For example, if your original data is in meters, the variance will be in square meters. Let's look at the example that we discussed just now to find the expected winnings. So we define W to be the random variable that represents the winnings in the game. We define the support of W, the PMF of W. Now we will find the variance of this random variable W. Now, according to the formula, variance of W is equals to EW square minus EW whole square. Now, again, you can use the original formula, that is E of W minus expectation of W minus expectation of W whole square. But I always prefer using this alternative formula because we already know the value of expectation of W. We have just found it. So we just need to find expectation of W square and we are just done. Okay, and how would we find expectation of W square? We have just seen that here W square is a function of W. So expectation of W square would be equals to summation K square times probability of W at K, where summation is taken over the support of W. Again, K can take value -10, -5, 5 or 10. Since we are finding expectation W square, so we will have -10 whole square times its probability, -5 whole square times the probability W times the probability of W at -5, 5 square times the probability W take at 5, plus 10 square times the probability W can take at 10. Now we know the PMF of this random variable W, so we know what would be the probability of W at -10, at -5, 5 or 10. So we put these values and we find that expectation of W square is 550. Now variance of W is equals to expectation of W square minus E of W whole square. We already have calculated E of W, which was -0.83. So variance of W would be 50, which we just calculated, that is expectation of W square minus 0.83 whole square, which would give you 49.3055. Now, as I said, so this is how we find the variance. While the variance is useful, having a measure in squared units can be difficult to interpret or compare directly with the original data. To address this issue, we use the standard deviation. The standard deviation, which is basically the square root of the variance. So the standard deviation of a random variable x is equals to the square root of the variance of the random variable x. By taking the square root, we bring the measure back to the original units of the data. The standard deviation tells you, on average, how far data points tend to be from the mean in the original units of measurement. In many practical implications, standard deviation is more commonly used and reported than variance, precisely because it's in the same units as the original data and thus more intuitive to interpret. Okay, for the same example, if we want to find the standard deviation, it would be directly equals to square root of the variance. We know that the variance was equals to 49.3055. If we take the square root of that quantity, we get 7.02. So this means on average, the actual winnings in any game tend to deviate from the expected value of -0.83 by about $7.02. So when we are trying to find the expected winning, it means that on average, you would expect to lose 83 cents per game if you played it many times. And standard deviation basically interprets that on average, the actual winnings in any game tend to deviate from the expected value of -0.83 by about $7.02. So this is all about expectation, variance, and standard deviation. I explained the simple meaning of what expectation means, what variance means, what standard deviation means. I hope it is clear to you all. I'll see you all in the next video.